So in this video, we're going to be looking at the derivatives of trigonometric functions. Now, the derivatives of trigonometric functions are relatively easier to remember than the derivatives of inverse trig functions. Inverse trig functions are a little bit more challenging to remember, and they can get a little tedious. But when you think about the derivatives of trig functions, they're slightly easier. So let's look at them. So let's look at the derivative of sine x. Just remember the sines and the cosines are always going to be like flipping each other out, except when you have a cosine, you're going to have a negative. So this is just going to be cosine x. But then when you have a c, that's just going to be negative sine x. Now, when you have integration in the next class or next semester, depending on what class you're taking, you would need to do this in reverse. So whenever you have like the integration or integral of sine x, you need to know which function's derivative is sine x, which is going to be of course negative cosine x, right? So you have to think about that one. It's going to be the antiderivative. So yeah, but that's not what you have to worry for this one. It's just going to be plain old derivatives of these functions. Next, we're looking at the derivatives of, let's look at the derivative of tangent x. These are the three main trig functions, right? This is going to be equal to, this is secant squared x. Now, secant and tangent, they have a relationship in these derivatives. So let's look at the derivative of secant x. This is just going to be equal to secant x tangent x. Notice how the secants and the tangents, right, they have kind of, they have only the secant and the tangent when we look at the derivatives, right? So that should be something that you can think about. Whenever you have a tangent, right, even when you look at the cotangent, you'll see that. Or let me do that right now. So d by dx of cotangent x, this is going to be equal to negative cosecant squared x, and then the derivative of cosecant x is equal to negative cosecant x cotangent x. And of course, this is multiplication. You can do negative cotangent x cosecant x. It's the same exact thing. Now, look at this. This is the pattern now. So tangent and secant, right, they have, when their derivatives only have secant and tangent in them, right? So tangent has secant squared, secant has secant and tangent. These two have a relationship. And these two actually have a very related relationship as well. Cotangent x has cosecant in it, cosecant has cotangent in it. These also have a relationship. Now the thing is, remember when you have these tangents, and here also you have technically the word tangent, the phrase tangent, but cotangent's different, but you have the phrase tangent. You always think about the square of the other term. So in this case, the other term is going to be cosecant, and then think about it as a square. And then when you have the other one, so that's just going to be secant or cosecant. Look at how they sound the same or very similar. This is just going to be the other one times this one. So the other one in the pair, that's going to be in this case tangent x times this one, which is secant x. And then here it's going to be cotangent x times cosecant x. Except, remember, when you have the c, you'll have a negative. So that's kind of a way to remember these two, right? These two right here, so this one and this one, this one and this one, they actually have kind of a pattern going on. And you can very easily remember this pattern. So remember one of them, and then you'll think about the other one as a pair, so it's very easy to remember. And then of course sine and cosine, they're quite easy. You should probably know them. Just remember that it's like a flip, except so cosine becomes cosine becomes sine, but whenever you have the c, and this is applicable for all of them, you need to think about the negative. So this is kind of a way to remember this. I would say that the derivatives of trig functions are not as difficult as the derivatives of inverse trig functions, but I have covered tricks to remember those in other videos as well.